Hi everyone. My name's Robin, and I'll be talking about R for transport planning. I'm the developer of a package called ST Planner, which is designed to support transport planning in general, but it has been broadened out from my initial research, which was very much focused on one specific application, which is a cycling tool, which I'll present in due course. I've presented some parts of this talk already when I visited Munster, but Edza will be very happy to know that it's much condensed, and towards the end I'm actually going to ask you some questions. So as I was writing these slides, I decided to remove loads of the technical content and make it much more broader, and this is a great opportunity for the R community to come together. It's not often that a global community comes together in one place, so I think this is a great opportunity to ask some more fundamental questions. So that's what I'm aiming to do, and it certainly builds off and links to some of the previous talks. So hopefully that it will be of interest to you. And I've just realized that there is one link already with the previous slide, which is I recently developed or just wrote some simple functions that convert between different representations of origin destination data. So that might be something where you can represent data either as like a long list of origin destinations or as a matrix, and it's very useful to be able to convert between the two. And you can do that with the tidyr package, but it's not designed specifically to work with transport data. So already I'm seeing loads of links between the things. And like the first speaker in the session said, it's all about not reinventing the wheel and building on the shoulders of what other people have done. And I've certainly built on the shoulders of other research in this, in ST Planner, but that's not really the main focus of the talk. So normally research starts with a research question or a hypothesis, but actually this research starts with a dream. So I'm going to skip the abstract because you've already read that. The dream is, imagine if we could create an evidence base that could help city planners move away from the current city designs where car basically takes up the majority of the transport infrastructure space. And imagine if data science could be used in this way to provide much more livable cities. So I'm quite open about my worldview. I believe in a rapid decarbonisation of the global economy, and I think people in this room have the skills available to help make that happen. So I'm quite clear about what the purpose of this is. It's unlike some of the presentations, I think it's very much applied to a particular area of application, which is transport planning, and there's an associated industry that works there, and I think it's very helpful if we engage with that industry. So let's go from the reality of the dream that I may have had last night to when I woke up, and this was actually taken this morning. I went for a little run around my neighborhood, and I ended up in this slightly compromised position. I tried to take a photo to demonstrate how little space there was for active modes, and a car went by just at the right moment. And I think this is in Toulouse, but in reality it could represent any city. This is how our cities are designed, or the vast majority of them. So it's certainly a big problem, but it's not a problem that we cannot solve. And in fact, we've already solved this problem once without data science. So in the 1970s, Amsterdam looked like this. This is a photo from Amsterdam that shows it was completely congested, and there was a political process actually based on road safety that led to change in policies and a big change of direction. And now anyone who's visited Amsterdam knows that some of the cities look a bit like this. I should say that my PhD research looked into energy use in transport, and the Netherlands still has quite high energy use overall, but at least in the city centres, it's very suitable for walking and cycling. And just to go back to this photo, I think it's interesting that it happened in the 1970s, and in a way it's frustrating, because what that proves is that you can solve the problem without data science, because data science didn't exist then. So maybe we're using the wrong approach. However, I'm sure that data science, broadly defined, can certainly help with this situation. And most countries aren't like the Netherlands, so we need to be much more careful about optimizing and using resources efficiently, and also experimenting which approaches work best. And this is something that R and statistics and applied statistics in general can really help with. So I've got a map. I'm a big fan of making maps, and you'll see a presentation by one of my colleagues, Jakub, on Friday, who's going to be talking about the geocomputation with R book that I'm involved with. And if you want to make maps, then you can check it out. But this is just one map that continues that story about the current transport system. And what this is showing is quite sad. It's deaths. These are avoidable road traffic casualties. And I was pretty shocked to find that road traffic casualties now are the #1 cause of death amongst young people worldwide, greater than war and famine and other causes. So it really is a huge issue that we're tackling. And it's also a major source of emissions. So I think everyone in this room is interested in a very important topic. And I just scraped some data from the International Energy Agency's forecasts, which go up to 2030. And the growth in transport is quite impressive. In many countries, this is the biggest, fastest growing sector in the economy. And if we're going to be in line with the Paris agreements to tackle global climate change, we basically need to reverse the direction of travel that we've been moving in. So that is a huge challenge, and it's going to require a huge amount of data analysis, but also political will. And I strongly believe that data scientists can contribute to the solution, which gets onto the topic of my talk, which is R for transport planning. So when I started doing, I guess, data analysis and, roughly speaking, transport data analysis, I was using a workflow where I was doing the modeling using R, and then I was saving the outputs as shapefiles and visualizing them in another program. I was using QGIS at the time, but I've also used other things. And that took a huge amount of effort to do. And my understanding of transport planning, and I've spent some time working with practitioners, is they tend to use a different program for the geographic data analysis and the visualization as they do with the modeling. And that creates a problem, and it prevents you from having an integrated workflow. So the huge advantage, the #1 advantage of a program like R, and I think other open source command line data science tools could do this also, is that it allows you to integrate all of your analysis into a single workflow. And we've already seen there's packages for trajectories analysis. I had no idea there were 52 of them, but there are. And there's also packages for doing models of spatial interaction, which you can use to estimate transport demand. And then there's also another ecosystem in terms of visualizing that data and communicating it. So the message here is that you can actually not only do your analysis, but you can also deploy the results to interactive applications. And if you want your research to make a difference, it's really important that you communicate it, not just in academic papers, but that you get it out there to the public and to the decision makers so that they can use this research. So this is an example that is called the Propensity to Cycle tool. This website's been up for about 2 years now, and it's being used by the majority of local authorities across England and Wales to help design strategic cycling infrastructure. And what it does is it just is a shiny application in the front end. So that shows that you can go all the way from the back-end data analysis all the way to actually deploying the application using an R framework. And I don't think there are many other frameworks that can do that. Also, to move on, transport inherently involves geographic data, either implicitly geographic, like with OD data that only has IDs and not coordinates, and R is excellent for geographic data. R, I think, is unparalleled in terms of reproducibility. Reproducibility is at the core of what R does. So I think that's another way that you can encourage people to use R for transport planning. And also, as I mentioned, visualization is vital for public understanding and the impact, and R is very good at that. So there's a growing R transport community, as we can see in this room. So the next few slides just kind of sketch out a little bit of what this may start to look like, but it's more about asking questions than saying this is R transport, because it's early days, I think. And then that raises the question, well, how do you think about transport planning in general? And it's useful to structure your ideas. And I think one thing that is central to all transport plans is this idea of modality. So you have different modes of transport, and applications tend to focus on one mode at a time, certainly in industry. So you'll have your walkability analysis to do the walking, then a government will hire us to do the cycling analysis, and someone else will get paid to do the car analysis. There's clearly a hierarchy to these modes, with the most vulnerable being walking, and then cycling, and then obviously you've got your motorized vehicles down there. And I think this is a really interesting way of looking at our packages that are out there. And I was also surprised to find that there's 2 walkability packages. I didn't know that there were any. So you've got something called movability, which is not yet on CRAN. You have 2 walkability API interfaces. So there's stuff on walking. And then in terms of cycling, I think programmers tend to like cycling. So there's quite a lot on cycling. I've just put a few examples there, which include Cycle Streets, which is another API package, and then bike data, which allows access to huge amounts of transport data. And you can install all of those, and I've tested them, and they work. So we actually have most of the bases covered in terms of modality. And what I think is interesting, if I go back to the hierarchy, our community is doing well in terms of providing more packages for the most important modes at the top of that hierarchy. You can also arrange it by geographic level, and I'm not going to talk about this in detail, but ST Planner is primarily about origin destination data. There's also a package called flows for representing not zones, but the travel between those zones. And then, as we saw, you've got loads of packages for dealing with trajectories data, and also, which is much more work in progress, these route networks. So there's a function and class in ST Planner called Spatial Lines Network, but there's, I think, huge potential to improve that. So there's a forthcoming article that has been in process for a few months describing that. So moving on to the questions, because I've only got 2 minutes left, and I do want to leave time for questions. I think we've got a lot of good stuff going on already in R for transport, and I think it shouldn't be too difficult to make the case to people who are using other tools in industry to switch over. I think we need to be thinking strategically about how we best do that as people who are using R and in favor of open source software. So a few suggestions first, and I'll come to the questions. I think it would be beneficial for the communication to be more about what's already possible. And as we saw in the first talk of this session, there's a huge amount that's possible that's not documented. So basically that means better documentation of the existing stuff, and I'm trying to do that in my own package. I think telling the story of how you did the research is really useful, so blog articles and stuff can be good on there. And in terms of how we move forward as an ecosystem, trying not to just reinvent the wheel. So if you're a developer, try and invite other people to contribute to your package. And if you're a potential developer, look around and see if you can contribute to another package rather than just creating another one before you do that. And then for everyone, make sure that you cite code. I think that helps a lot, and I think that research has got much better at that. And finally, communicate and collaborate. So finally, questions to the audience. Is there a need for some kind of grouping together of transport people? I don't know, a transport verse. And I should say there's already something called tidy transit, but that doesn't seem to cover all modes. And also, how can we best take this forward? Thank you very much.
Thank you, Robin. So I guess time for questions or to answer Robin's question yourself.
Hello, I have a question, and also I share a little bit the dream, but I'm coming from a completely different industry, which is aviation, and R is nowhere there. I have a lot of problems to find some support instead of starting from scratch, and I think it will help even in your dream to try to bring other means of transportation into the picture. So are you aware of any people involved in...
On aviation particularly?
Yes.
So yes, certainly. So there's something called Skynet. It's not the online game framework, but there's an R package. And this is actually a good news story for me, because someone came on a course that I taught, and they were quite new at learning R, and then next thing I knew, I saw on Twitter that they'd actually got this package onto our OpenSci, which is peer-reviewed. So Skynet is much more about the data processing side of transport. So if you want to get hold of the aviation data, this allows you. I think it's US focused, because on a project that I'm working on, we need to look at aviation data, but it doesn't cover the UK, or it doesn't mostly cover the UK. But I would say Skynet is there. And the second thing I'd say is be the change you want to see in the world, and go for it.
Yeah, I'm coming from the civil aviation side of international organization.
Okay.
We have the data, but I'm trying to...
So yeah, and there are plenty of people who will be able to develop packages for you. So yeah. So thanks.
I'm curious, are you aware of any existing tools or database that planners use, and us as our developer can help interface and expose it to the larger community?
So that's a really good question. So you're talking about interfacing to existing software for transport?
Planners, tools, yeah.
Yeah, so I think that is a very good question. And if we don't want to reinvent the wheel, we shouldn't really try and redo what's already been done in a different language. So Sumo is a open source microscopic transport model, so it can actually model individual entities on the road network, as the GIF there is showing. Unfortunately, I can't say there's an R package for it. So myself and a colleague, we started looking into it, but we didn't have the capacity, partly because we're not Sumo users. And also, there's loads of other things to do. So I think that's a really good point, that maybe effort to interface with other software. There's also NLRX, which interfaces to a agent-based modeling software, but that is not really transport modeling software. So that's quite abstract, agent-based modeling. But I think that's a very good idea. And other than those two, I don't really know of any. And I don't think it's worth trying to interface to some of the proprietary products that are represented in this slide that I didn't get to talk about for reasons that I won't go into. So yeah, thanks.
So in Germany, there are companies like Init or Bedisys which perform these services for transport planning things. So who are the potential users for your package?
So who are the
So
potential
there are
users?
like several companies doing this. So who do you think are using this package?
So this product was developed for the Department for Transport. I suspect we might be behind a firewall at the moment, so I'm just going to show the landing page. So the target audience is local authorities. So local authority planners are using it to identify a route network where they can deploy it. I think because of the firewall, it's not going, but this is really being used to a large extent. So we did a very brief review, and we found that in terms of planned cycling infrastructure, our tool is being used to inform £500 million worth of investment in cycle networks in the UK in the next 10 years. So that's big, but also what we found is that there's a legal process whereby local authorities in the UK must design cycle networks, but they don't have the capacity, they don't have data scientists in most local authorities in the UK, so they're paying consultancies to do it. So actually, we've learned of many local authorities who are downloading the data and using it, but sometimes repackaging it and selling it on as their own stuff. So that raises a whole load of interesting questions. But generally, transport planners are the target audience.
Okay, thank you all so much. I think we have a 30-minute break, and our presenters are in the room if you have any more questions and want to talk to them. Thank you to all of our presenters for introducing us to new ways of thinking about movement and transport. So thank you again.
Thank you.